Hi everybody! Today we have problem number 16 of 2006 American Mathematics Competition 10A. A circle of radius 1 is tangent to a circle of radius 2. The sides of triangle ABC are tangent to the circles as shown, and the sides AB and AC are congruent. What is the area of a triangle ABC? If you want to try this one for yourself, now is a great time to pause the video. Alright, let's get to the solution. So, first thing that we are going to do is to resketch the radius of the small and the big circle so that they intersect the leg of our isosceles triangle at the 90-degree angle. We will mark those intersections as D and E. Now we will mark the intersection between the height of our triangle and its base with F, and the centers of the small and the big circle as O1 and O2. Now let's isolate the right triangle ADO1 and also isolate the right triangle AEO2. We can see that these two triangles are similar to each other. That means that we can use the rule of similarity of triangles that states that relation between sides AO1 and AO2 must be equal to the relation between sides DO1 and EO2. Now, if we take a look at the sketch at the left, we can see that the line AO2 is equal to the sum of lines AO1 and O1-O2. So we can substitute that into our relation, and we get that AO1 over AO1 plus O1-O2 must be equal to DO1 over EO2. Now, if we take a look to the left, we can see that the line O1-O2 represents the distance between the center of the small and the big circle. And in this case, since two circles are colliding with each other, that means that that distance is equal to the sum of their radius. In this case, that is equal to 3. So we can substitute that value in our bottom equation. And we know that the lines DO1 and EO2 represent the radius of our two circles, so we can substitute those values as well. Now we are left with our new equation. We can cross-multiply these values, and we will get that 2AO1 is equal to AO1 plus 3. Now we can work through this, and finally we will get that AO1 is equal to 3. Now let's again set our attention to the left, and again let's look at the triangle ADO1. Since we know that the line AO1 is equal to 3, we can easily find the line AD using the Pythagorean theorem. So AD squared must be equal to 3 squared minus 1 squared. That means that AD squared is equal to 9 minus 1, the AD squared is equal to 8, and that means that AD is equal to square root of 8. Great! Now let's again isolate our blue triangle ADO1, and with it let's isolate this purple triangle that represents the half of our isosceles triangle ABC. This purple triangle will have the vertices of AFB. Again, we can notice that these two triangles are similar, so as before we can use the rule of similarity. But first, let's try to find out their sides. We already know that AD is equal to square root of 8, and we also know that DO1 is equal to the radius of a small circle, so that is 1. Now let's take a look at the line AF. On the left sketch, we can see that AF is actually the height of our isosceles triangle ABC. And we already know that AF is equal to AO1 plus distance between two centers O1, O2 and plus O2F. We know that the value of AO1 is equal to 3, the distance between center is 3, and O2F is actually the radius of the big circle. So we can substitute those values. and we get that AF is equal to 8. Now let's try to find the value of the side BF. We will mark it as x. So if we use the rule of similarity of two triangles, we will get that the relation x over 8 for big triangle must be equal to relation 1 over square root of 8 for the small triangle. If we cross multiply this, we will get that x times square root of 8 is equal to 8, and that means that x is equal to 8 over square root of 8. If we rationalize this by multiplying it with square root of 8 over square root of 8, we will get that that is 8 square root of 8 over 8, and if we simplify, we will get that x is equal to square root of 8, and if we simplify more, we will get that x is equal to 2 square root of 2. That means that the side BF is equal to 2 square root of 2. In terms, this means that the whole base of our isosceles triangle must be equal to twice as that, so that is 4 square root of 2. Now, if we erase all unnecessary data, we can see that we have the base of our isosceles triangle ABC, that's 4 square root of 2, and its height that is equal to 8. Now all that we need to do is to calculate the area of this triangle. We already know that the area of the triangle is equal to the base times height over 2, so we will substitute our values into this formula and we will get that the area is equal to 4 square root of 2 times 8 over 2, that is 32 square root of 2 over 2, and when we simplify, we will get that the area of our triangle ABC is equal to 16 square root of 2, and this is our solution. Hope you guys enjoyed this video. If you did, please give it a like or subscribe, it would mean a lot to the channel, and until next time, see you guys, bye bye.